Hello everyone, this is Mrinal Kanti Roy Choudhury. The title of the talk is Some Research Perspectives in Quantization. Quantization refers to the process of approximating the continuous set of values in the image data with a finite, preferably small set of values. The input to the quantizer is the original data and the output is always one among a finite number of levels. It is a process of approximation, and a good quantizer is one which represents the original signal with minimum loss of distortion. These problems originate in information theory and engineering technology, such as image compression and data processing. In quantization, people can work in two different directions as follows. Finding the exact configuration of an optimal set of n means, which corresponds to the support of the quantized version of the distribution for any positive integer n, and estimating the rate called quantization dimension at which some specified measure of the error, also called the distortion or noise between the quantized distribution and the original distribution, goes to zero as n goes to infinity. Recently, M. K. Roy Choudhury, along with M. Pandey, has introduced the concept of constrained quantization, and it extends the current theory of quantization to the theory of constrained quantization. Current theory of quantization is a special case of constrained quantization. After the introduction of constrained quantization, the overall quantization theory has now two classifications: constrained quantization and unconstrained quantization. Further, Pandey Roy Choudhury have introduced another new concept in quantization theory, which is called conditional quantization in both constrained quantization and unconstrained quantization. After the introduction of constrained quantization and then the conditional quantization, the quantization theory is now much more enriched with huge applications in real world. Finding the optimal sets of n points in constraint scenario, or n means in unconstrained scenario for a probability distribution is much more difficult than to calculate the quantization dimension. It is much more engineering and applied. Optimal sets of n points or n means are still not known for a huge number of probability distributions, except for a few in the case of uniform probability distributions. There are many researchers who investigated the quantization dimensions of different probability distributions in unconstrained scenario. As constrained quantization is newly introduced, there are many things need to be investigated in constrained quantization dimensions, both in singular continuous probability distributions and absolute continuous probability distributions for the development of the constrained quantization theory. Here are some significant open problems. Let P be a uniform distribution. You can consider any probability distributions, but for simplicity, take P as a uniform probability distribution on a region. One can take a disk, a square, or a regular M-sided polygon. Let L be a line or a curve on the region. How to determine a constrained optimal set of n points for P taking L as a constraint is not known yet. Big data set. How to represent a big data set by a smaller data set lying on a fixed line or a curve is not known yet. Fixed line. You can take any line as you wish. Such a problem is a significant, highly significant open problems in machine learning areas. Open problem number 3. The universe can be considered as a unit sphere. That is a sphere with a center as the center of the earth and the radius as 1. Such a sphere is called a celestial sphere. Notice that a plane intersects a sphere in a circle. Such a circle is called a spherical circle, and the arc of a spherical circle is called a spherical arc. If the center of the earth is also the center of a spherical circle, it is called a great circle. Any 2 points on the sphere can be joined by an arc of a great circle. A triangle is called a spherical triangle if the sides of the triangle are the arcs of 3 great circles. For a probability distribution which support a spherical arc, a spherical circle, or a spherical triangle, the optimal quantization is not known yet. If such a problem can be solved, it will generate many, many new open problems which will have a huge applications in space research. I would like to tell you now about the important references. Centroidal Hornet oscillations, applications and algorithms. There you will see many information how quantization theory can be applied. Foundations of quantization for probability distributions by Grafenology is one important resource to learn quantization theory. Then here are the 3 papers of Pandey Roy Chaudhary about where they have introduced constraint quantization and conditional quantization. Thank you for listening.